Hello, everybody. So today finished the lecture for module 7, which 7 of 8, we're pretty much at the end of the semester. It's getting really close. I have some odds and ends to kind of fill up the rest of our time, but the bulk of the stuff we're going to wrap up the last major content today. One thing I know I'm going to what we're going to look at next Tuesday is something I like to go over in this class because it's something that's not covered anywhere, but I can't really guarantee that nobody's going to need it. And that has to do with the image formats. Right? When we use a file, we just download the picture we want and then stick that in the place we're going to use it. And we don't ever think about what's happening internal to those. The graphic design people don't even cover the internal differences between like a PNG and a JPEG and a bitmap and SVG and what's different about the file. So I like to cover it somewhere, and it looks like we'll have a little bit of time next week to cover that. Talk about those differences. Just like it's not covered anywhere in IT, and graphic design people don't even cover it. Right? We just find the image we need and then we use it. But sometimes that internal difference does matter. So I like to cover it somewhere. Hopefully it's at least useful for curiosity. Like maybe you've wondered why PNGs and bitmaps, you can make them smaller and they're still clear. But a JPEG, if you make it bigger or smaller, if you change it at all, it gets blurry. If you change it and it gets blurry and you try to undo that change on a JPEG, it's still blurry. You can't undo the blurriness. And the reason for that, talk about stuff like that. I like to work that in somewhere, and I think we'll have time for it next week. One more thing that falls under the category of survey of the School of IT. What we've been doing most of this semester, looking at all the different aspects of the programs of the School of IT. And that has to do with cloud technology. Cloud's kind of a big thing. It's often just generically refers to anything. People use it to mention anything online, but cloud is, when we say cloud, it is something specific. We're going to look at AWS. A lot of them are the same. There's some standards. We're going to look at AWS. That is by far the most popular one. But Google Cloud Platform, GCP, it uses the exact same standards as AWS. And for the most part, the buttons are even in the same place. They're a different color. I go with GCP sometimes. I recently shut mine down because there was a billing issue that caught me by surprise and like tripled my bill 1 month. And I was not happy about it. But I would usually go with GCP because I like the color pattern they chose on their website better. They're basically almost identical except for what color they made the buttons. Oracle Cloud, Azure is Microsoft's version. There's lots of different ones out there we can choose from. We're going to look at AWS today. By far the most popular, very reliable, but just talking to people around America, you've probably noticed that some people they'll say cloud when they're referring to the internet. Anytime they put something on the internet, they start referring to that as cloud, but it is something specific. As a methodology of how we do things. And it ties in this week because remember the other day we were looking at virtual machines, virtualization. So we virtualize our network components. Instead of like that picture I drew back in the networking week, right? We have so many client machines and switches and all of the switches and routers and all of that stuff. And then a big powerful server somewhere managing our network. Or On most networks, probably more than just one server. Probably have a lot of servers doing a lot of different things. Physical hardware that gets expensive. But like we were talking about the other day with virtual machines, there's a safety factor because we don't mess up our expensive physical hardware. If we do a virtual machine of a virtual server, well, if something goes wrong, we just delete it and replace it, and we don't have to go replace a very expensive physical device, because servers usually cost a lot more than the client machines. We probably have a backup copy of our server, so it's kind of leaning in that. And what we really mean when we're talking about the cloud kind of takes that to the extreme. So instead of everybody having their own setup like this on those big powerful server farms, there were several in existence. We're going to look at AWS. So Amazon, as big as that company is, they have just warehouses full of servers, and they don't need all of them all the time. So on their server, I'll just draw one, but they'd have a warehouse full of them that could handle their peak load. But most of the time, I'll maybe make this like a meter. I'll draw like a meter here. Most of the time, they're only using that much of the server for their own needs, which means all of this stuff is available. And they have a whole bunch of servers doing that. So there's lots and lots of room there available. So they could lease that out to people and make money, and that way the server is not sitting there idle. They might as well lease that extra space out. And they set it up so that it's dynamic. I'll color code it. Then somebody can use that part of the server. Or somebody else needs a little bit more, they'll set up a bit like that. Like somebody else uses that section of the server and they just lease it while they need it using virtual machines. So like we saw the other day, each one of those would be an independent VM. And if this person suddenly needs a little bit more, right, their site suddenly takes off in popularity. Their ad campaign just ran, so a lot of people jump to the website and they suddenly need 3 times as much. Well, that's just a virtual machine. It's a piece of software. We can make a copy of that and spin up 2 more of the exact same thing. And then a few minutes later, at least a little bit more space from Amazon on their server. And a couple hours later, people have forgotten about that commercial they saw in the middle of the afternoon. So they stop going to that website, and we don't need those anymore. So we can turn them off, and we get that dynamic. We get a dynamic application by setting up our virtual machines and scaling them to fit our thing. And that's sort of the starting point of it. It goes a lot further than that. So all of our components, we can kind of virtualize those. Everything we would need. It doesn't have to be our entire setup at once. We can break it down to the smallest piece of what we need. Like maybe there's a script that has a couple of functions, and we can break it down to just a single one of those functions in one particular script, and just only spin that up as a virtual machine when it's needed, when somebody asks for it. That in particular, right, it's like one function is going to be just a couple lines of code, so it doesn't take any time to spin that up. A human, even if it wasn't even loaded onto the machine, by the time it copies from another server, spins up, talking like 5 lines of code or something, it's not going to take any time for that. A human wouldn't even notice the difference compared to the normal time of loading a web page. So we get this dynamic capabilities of our network. That's a starting point. Obviously, it gets a lot more detailed. I just wanted to sort of introduce it there. I'm not sure if I'm not going to point to that anymore. But I started erasing that, and I like this picture a little bit better. In the future, I might start drawing the picture and then erase part of it, because this is a big server farm. We can keep doing this all day long. And once that started, then they added a whole bunch of blank servers to keep doing that. There's capabilities of crossover. Like if I draw the red box around like this, so that the red's not even using all of its box. And the blue suddenly needs a little bit more. It doesn't need to spin up a whole another server. It just needs a couple more bits of RAM for a few minutes. It can borrow it from that. And then we're like at nanosecond time scales and come back down. So we don't even have to spin up another virtual machine. Things are interconnected. And it gets very detailed. It is an entire degree program to study here. But usually we set up those little virtual machines instead of the expensive physical ones, lease some space from Amazon or Google or Oracle or Microsoft. There are some new ones cloud specific, but for the most part, the big ones are all companies that already had a server farm. So they already had tons of servers and just extra space to lease out, and they just extended from there. Last week, I did this right before we went over to Amazon this week, the footprinting lab for cybersecurity. Did anybody put those coordinates in Google Maps to see what that was? It looked like a whole bunch of people had the right coordinates. Let me pull them up real quick. There was two. Somebody fell back to the Kansas City one. I think most everybody got the Virginia East coordinates. I'm going to pull them up and I have to I'm going to copy from one of y'all's submissions. So I have to go into the grade book. That's why I'm not sharing my screen right now. Probably should have copied and pasted it before class, but there was some Qdoba and I had like 10 minutes to shove chips in my mouth. I spent my time doing that, not copying the thing I knew I was going to need at the beginning of the class. They were really good chips though, and chicken and beef and all that stuff that Qdoba sends. So I have to go in the grade book to grab one of them, and then I'll share the screen. The one in somebody spelled back in Kansas City, which is really nice because if you put that in Google Maps, you see a big a vacant lot. It still has labels of businesses that used to be there, but there's currently not even grass on the spot. It's a big muddy plot in the middle of downtown Kansas City. Let's see, module 6 lab. I think everybody had the right coordinates in there. Let me see if I can copy and paste from this one. Oh, not that. They moved my buttons. Oh, there it is. Canvas updated, and I've developed habits of clicking the same buttons over and over again. Oh, whoops, that's not the one I wanted to open. Open bins. I just created yours this morning. I know it's in there. I think it was this morning. It was fairly recently. So it had the right coordinates. I've seen them quite a few times. I didn't have to really look. Copy that, and I will put it over in a like text file, and then I'll share my screen. So here's the coordinates of where the one in Virginia is. I think it was George. His fell back to Kansas City, so the one in Virginia was probably busy. Remember how we have the 3 different IP addresses? There's multiple servers in Virginia or this thing. Maybe he did his homework at a time when the one in Virginia was just completely full. So it went over and spun up that virtual machine in Kansas City and a server 500 miles away. And he wouldn't have, doing his homework assignment wouldn't have looked any different than anybody else's. Right? All that happens in the background is there, of course. So I'm just going to take those latitude and longitude coordinates. All you need is the numbers with a comma and paste that into a Google search. And on maps, here's where that is. For the, in particular, the big one in Amazon's main one in the east half of the US is Virginia East. If I scroll in, or the labels coming up. Yeah, so notice in particular that it's right next to an elementary school. That kind of makes a difference here. So if I go to satellite view and start zooming in here. So here's the elementary school. We're right over here, and we see a baseball field, and it's in the trees, but there's a really nice playground here. If I zoom way in and do the street view, there's my little street view guide. It's probably where I hide zoom buttons. Those don't need to be on the TVs. Yep, here's my hidden zoom buttons. Bring over the little street view guide. I'm right near it. You can see there's some nice, looks fairly new playground equipment there. And we're looking at a parking lot. Oh, there's the new stuff. So right next to elementary school, we put the coordinates for AWS's main server farm. This is what we see. If I keep turning around, yeah, then we see this. So notice there's an extra door on the building with the restrooms. The extra door has some stairs going down underneath that baseball field, and that super nice playground they built for the kids is where all the servers are, because servers don't need a window. Servers don't complain if they don't have a window office. There's no need to put them above ground. The one in Kansas City is brand new. They just moved to a different location. So if we put those coordinates in, we just see a muddy field that's catty cornered from the city hall in Kansas City. So right in the middle of it. Google Maps still shows those things, but they build really nice parks and stuff, right? Nice walking trail. This one's right next to an elementary school, so Amazon went ahead and put a fairly large playground area, more than one playground actually. You can kind of see more stuff down there, and there's, depending on the view, there's some other ones, but it doesn't look like what we would think of with a server farm, right? Probably think of a server farm in a big warehouse or a fancy looking building, all that stuff. They're just Amazon put it underground, and they put parks above almost all of them. So it's really nice. If they're in a natural place where a walking trail is good, they put some really nice walking trails. Like the one in Virginia, if they're near a school, they give the school a really awesome playground. And servers don't need windows. They kind of do need the air conditioning. So windows are bad for server farms. Underground, it's easier to keep it cold and all that stuff. So that's where those are. But we don't have to access them. We never access the hardware. We're leasing space for it. So we're paying for that, the hard drive and the RAM and the bit we're going to use. So Amazon can pay somebody to keep up on that. Did everybody get that email about the AWS stuff? Everybody except click the button in the email. As he head nods, do I need to send any more, resend any of them? Let me log in from this, and then I also sent myself one to my personal account so that I can log in as a student and do the same, see the same thing you all see. Let me see if I'll just go ahead and jump in, since I'm already this far. I'll just go ahead and jump in here and click resend anyway, just make sure it's there. So Cloud Foundations. There's people. So I'll just go ahead and hit resend. Okay, so it should be at the top of your inbox, or will be in a split second if you can't find it. I'm going to log out of this and go to my own personal email, because I also sent myself one. Okay, start. And after you click the button, it's a good idea to keep that one around because it'll link to it. This will be open until the end of our semester. So I used to keep them open longer, but nowadays Amazon draws the close dates right from Ivy Tech. So I suppose the day of our semester, it has the end time of from Ivy Tech. So 11:59 p.m. on July 30th this semester. It's going to shut off. We have until then, and you'll be able to just kind of come in here and click around and play on stuff, see what's going on with it. So I'm going to log in with my personal account, kind of see the same thing. So when you log in, you should see something like this. And this is an active subject we learn by doing. So I was wanting people to follow along, or if you prefer, do it at home later. But it'll be for points. So along the way, we'll take some screenshots. I will try to remember to take a screenshot of this, but if I forget to say that, just take a bunch of screenshots along the way and send those to me. And it'll be the same as the last in-class assignment. I think it was 15 points, 20 points. It wasn't very much, but it'll be the same number of points as the last one. And just show me that you're following along with it. I'll try to remember to say take screenshots. So you probably recognize the Canvas learning management system. Ivy Tech likes to customize things, make it green. At Ivy Tech, make it green, put the Ivy Tech logo over everything. But it's Canvas is the product that started as. They use the same one here. If we go in modules, this particular one that I signed you up for, I use labs and from the AWS Academy in a number of courses. So I usually open several every semester. This one was actually intended to accompany the AWS Cloud Practitioner certification, to prepare for that certification, which is the one that that is connected to the SVAD 150 class, SVAD 150, which I think a lot of people have to take. I'm not sure who all has to take it, but I think like half the schools of IT have to take it. At least the introduction to cloud stuff. So there's a bunch of modules there, but if we scroll way down to the bottom, after all the modules, typical list is preparing for that, there's one called a sandbox. And a sandbox is just an environment we can go in and click around on. We don't have complete unrestricted permission like if we were to go buy our own AWS account, which there are free tier accounts. You have to enter your credit card number, but for most of us, Amazon already has our credit card number. So we don't even have to type it in again, which is, I don't know, I didn't. I just used the one that Amazon already knew, and it worked fine. And using all free tier stuff, it doesn't cost anything. It just, I guess they want your credit card number in case you do something that costs money. But there is free tier stuff, so like small servers, just a little bit of storage. If you just need to do small things, it doesn't cost. You can do that without much cost, but it's not very expensive either. And you pay for what you use. Like in this picture, the one I color coded in blue here is going to have a much smaller build than the red one. Because they keep very, very accurate track of everything you do on there, and you pay for just the part you use. It has advantages and disadvantages. Trade off like the traditional one, you buy the hardware up front, you're paying a lot of money, but you know how much you're paying, or the monthly bill comes out. So there's no surprises. That's why I recently deleted my Google Cloud account, because somebody else's process passed through my server, bounced through my server on the way through, and whatever they were doing ran it. It made my server, they thought a website or a web page got 1 billion hits in like 3 hours. And they wanted to charge me a lot for that. That was $39. So if you have a website that gets 1 billion hits, it's like $30 a month. But I did not have that. I had one page where I was testing something. And it was really, $30 was a lot for that, but the prices generally aren't bad. So in the sandbox, we can click around for free. And AWS Academy, a learning environment. I guess it took them by surprise. We want to click the Start Lab button. So when you get here, click Start Lab. It takes a minute to spin up. I guess it took them by surprise, but apparently some people would run their business from the free educational versions. So they tried to restrict that and do some stuff. Lock some things down. We don't have permission to do anything that wouldn't be part of this module. Like the software development stuff. I can't use the AWS course that's designed for practicing for the cloud practitioner exam in order to create a CI/CD pipeline. That's continuous integration, continuous deployment. So instead of the old things where we have like version numbers, version update patch. So like version 3.7.14 of our software. Every time somebody opens the code, they never actually install the code. So every time they open it, they just download the latest version. Then we don't have issues with users refusing to update or something. The it continuously deploys. So every time they open, it's the latest version. Can't do that on this. I have to go over to like the cloud developer AWS course to have permission for that. And then that one has some things, the permissions on here that aren't on there. So they tried to lock it down. People are still doing that though, which for some reason surprised Amazon, but does that surprise anybody in here? And I've yet to see anybody that's actually surprised by the fact that people would run their business on the free educational version. So it does take a moment to spin up. Shouldn't take too long. Sometimes it takes longer than others. But you'll see right here, 180 minutes. So basically, we're not going to burn through 180 minutes on this thing. You put it down and start again. There's a small budget. I don't know what the budget is on this one. Oh, sorry. Okay, yes, I did say something, right? If y'all want Qdoba, there's Qdoba right next door.
We'll leave the lights on.
Okay, are you out of here for today?
I am, thank you.
All right, I'll see you tomorrow. Yeah, it sometimes takes a minute to spin up, but I don't think this one has a budget list. I'll check when we go back to the other screen. But it's like $140. It's enough to last through a whole semester. So if you left a bunch of stuff running, if you turned on all kinds of stuff, way more than you would need to study for any given class, and left it running for the entire length of the semester, then you would burn through that budget. So it's enough for that. This 180 minutes is, or 3 hours, is before it shuts down and you have to start another one. So you have until the end of the semester to click around and play on stuff. Hopefully it won't take too long to spin up here. And we'll just look at some of the basics today, how we create our little virtual server machine so we can do things. The other day we talked about Linux stuff. Has anybody done that lab yet? Installed a Linux machine? I know you said you're already a Linux user. So once we spin up a server, then it's just a Linux machine. So you probably already know what to do on it, or have at least a good idea on how to start with it. Oh, there it is. So eventually it says lab status ready. Some of them are different. I like that. Some of the screens, you'll click that, and then there's like a little dot over here. It starts red and turns yellow while the lab's starting, and then it's green. I think that's a lot better than the big message box, the typewriter. But once it's started, you click this button here, it says AWS. And that will open our console. And if you were just go create an AWS account, you would see something. This is what you would see. It does have dynamic buttons. This is one of those sites, the buttons change. Not just the recent list. It will try to predict what buttons you might need based off off the recent list. So you'll see the recent list and then the buttons are always moving. So the search bar is helpful. It is one of those sites that you have to look for the buttons because it tries to respond to what you're doing. And there's machine learning algorithms. So the more you do stuff, the better it's going to get at that. But especially at first, it's not going to be very good at predicting what you might want. Up in the top left, see the button that says AWS. If you start to get lost, there's a lot of stuff going on here on the web interface. That button in the top left is always available, and that brings us back to the home page. So I guess that's kind of standard, but then the next one, services. This shows all of the things we can do. They're in alphabetical order, but analytics, so we can see all the measurements about our stuff. How much traffic did our server? How much traffic have we seen on our services? Whatever that server's doing. Bless you. Application integration, some cost management stuff, so they have things so you're not surprised by the bill at the end of the month. You can track it along the way and get the predictive line, see what it is so far, and decide if you want to turn stuff down, turn off that scalability function because your bill is getting kind of high for the month. Like, okay, yeah, let's just stick with the minimum for the next 10 days or something. I think most of us have done that on our phone, right? Some months we get near the end and it's like, oh, this phone bill is going to be huge. Rather not charge my phone for a couple of weeks and I'll just call everybody back next week in the next billing period. Lots and lots of different things, databases, containers. That has to do with pushing software out. It's kind of like a virtual machine. So traditionally, we put a picture up here. This relates to something. This is something you're going to hear about because we talk about this a lot. Or we talked about software. Bless you. So there on our client machine, traditionally we would have a piece of software. I'm going to draw it like a file. I'll draw the file icon. And we would take that file that has instructions, the software, and we would just install that right on the user's computer. There are a couple disadvantages to doing it that way. What a container is, and this has to do with that thing I mentioned earlier, the CI/CD pipelines, continuous integration, continuous deployment. We have no idea what that user's configuration is, nor do we have any idea if they're going to keep it that way. Right? Somebody might go digging around in the hard drive and be like, "Oh, I don't know what this file is," and delete it. And our software critically depends on that. So a better thing to do, and this is what containers are, is we make a little bitty virtual machine. We make a little bitty VM, and then us, as far as the software developers, are in charge of that virtual machine. We control the configuration and everything on that, and then we put the virtual machine onto their computer instead of the software. We put a virtual machine that we know is going to work to run our software, and we put that on there, and then that virtual machine is not going to crash unless they just destroy their entire computer. And then they hopefully we won't get blamed. Hopefully they won't run to social media, right? Like, just no telling what users are going to do. Install our software, spill coffee on their computer, pull out the phone, jump on Facebook, and tell everybody they know that our software had a bug on it or had a virus that destroyed their computer. Never know what people are going to do, so we want to take precautions, and that's container as a verb. We call it containerizing our software, and then the software developers in charge of it. So much more reliable way to do that. Front-end web and mobile. Game development is actually game deployment. That label is wrong. So this is This is servers with lots of sockets set up so that it's already ready. Pre-configuration. So we don't have to just set up a blank server. That's what we're going to do today for our introduction. We're going to set up a blank server. But we don't have to set up a blank server. We can set up some pre-configuration ones. This is not game development. This is game deployment. Servers that are already set up ready for hundreds or thousands of users to connect at the same time and play that game interactively. And then we load our game onto that server after it's already developed. That label has been bothering me for years and they still haven't changed it. They're in like the fourth version. They keep upgrading the stuff on the background, and like three different things have been deprecated and they still call it game development. But it's game deployment, which should make sense if we're talking about servers, not text editors. Governance stuff, you see there's a lot there. All sorts of things. I was looking at this in the other class. So Cloud9 does anybody use VS Code for text editor? You seen VS Code? Cloud9 is VS Code. It was originally intended to be a web application, which was the nice thing about it when it was created, because there was no really nice places to write code in web applications. Microsoft just took that open source project and changed the name and released it under a different name, the exact open source thing, and that's what VS Code is. So this is the original one, the Electron framework running there. But if you're familiar with VS Code, it's just like that on there. Code Commit, which is Amazon's alternative version to GitHub. Looking at those in the other class, so code repositories, lots of functionality like that. Pipeline, which won't even work here because I don't have permission to run it. This particular class, that's the thing I already mentioned, the CI/CD, continuous integration, continuous deployment. So no more versioning our software. Every time somebody sends open, the start button that we give the user, so it's like this, sort of the modern way of releasing software. So like this is the old one, right, where we'd have version 3.2.5 or something. And that's our virtual machine. The CI/CD is, we keep this over on the internet somewhere. And all we install here is just a little icon. I don't have any room, so I'm just going to write the word icon there. A little icon for the user to click on, and that icon runs over to the internet and grabs that. It's not ever installed locally, so we're even another layer safer away from the user changing their configuration files. That could mess up our software from running. It just goes and grabs it when it needs it. And then we can set it up so that it's always the latest version. No longer any need to update or anything like that. So we want to spin up a server. There's lots of servers, and all that stuff I just looked at, those are just categories. If I click this one for compute, you'll see there's a whole bunch of options on how we compute things. App runner, we could just set up, if we have an application, we could just set things up to launch that one application. Not even this way, that's a web application, so that's not even like this. More than one way we can do that. Batch is like, that terminology goes to the old mainframes where we had the old days of punch cards. Everybody's seen those in history books. I see head nods. Haven't been around in a while, but each card would have one instruction. You're running through at a time. So a big stack of those cards is a batch of them, a batch of instructions. So we still use that term if there's a bunch of things to do. So like at the end of the day, end of a work day, we want to back up the database, make sure everybody at the office logged off of their machine, power down all the machines, but make sure they're set to power back up at 7 o'clock in the morning so they run updates and everything before everybody gets to the office at 8 o'clock. All that stuff that we're going to do a bunch of, we can set it up to do as a batch. EC2, that's what we're gonna go. That's elastic cloud computing. That was the starting point, right? There's tons of stuff here. We're definitely barely scratching the surface. But elastic cloud computing is the picture I drew here for the basic introduction, where it's scalable. We're running this machine. If we suddenly have a lot of traffic, we can just make an exact copy of that. It scales up or it scales down. Or the thing here, if it needs to borrow a little bit of RAM from a virtual machine that's not busy nearby, it doesn't even have to take as much time as it takes to spin up another machine. They can just borrow a little bit of RAM from somebody else's virtual machine. Or temporary storage, that's the place that probably gets borrowed the most often. There's a little bit of storage like file transfer. Somebody needs trying to transfer a 3 gigabyte video or something. It's going to fill up the buffers. We run out of storage space, but we're maybe 100 kilobytes short. But the computer next to us has 100 gigabytes of storage available. We can just throw the rest of the stuff on there for temporary storage in that split second. It's elastic, like stretchy. It stretches and shrinks as we need it. That's what we need it to do. Lambda is where we would run a single function, like just one piece of code, one little section of code that we might need to run quite often. Just pretty good things. There's a lot we can do, and like all these we saw databases. There's a bunch of types of databases. So document DB, DynamoDB, Elasticsearch, key spaces, and a long list of these. And this list here only has the most popular stuff. There's even more. So mostly we're going to search for what we want. In our case, you go to compute and then EC2. This is where we just create a blank server. That's what we're going to do for our example today. Just set up a quick blank server, do a couple things. Probably not much more than what you do in the virtual machine lab this week, but kind of see where it is. So we call it an instance. So we need to go over here and create one. You come over services, compute, and EC2. It goes right to the dashboard. And if we scroll down just a little bit, you'll see an orange button that says launch instance. Click launch instance, we can set up a new one here. Names and tags, we want to be able to identify it, right? This used to be something that was done afterwards. Really, I like that it's at the beginning now. I'm going to call it class example, but give it some sort of name so that you will recognize it. Names can be a little funny at times. Some things on the cloud have to be globally unique. You have to come up with a name that nobody else in the world has used. Some things can be unique to your account. So you just have to come up with a name that you've never used before. This is one of the ones that it just has to be something that you've never used before. Then we choose our operating system image. So we saw that the other day with the VMware example, or it's in your lab. You download the ISO file and upload that. All of that's going to happen in the background because we're nowhere near the server farm. I can see right over here. It's in the Northern Virginia one, so that's that one we just looked at on Google Maps underneath that playground. I'm just gonna go with the Amazon Linux. That'll work for now, but you can see we have Mac machines and Windows machines, Ubuntu, and the list is huge. Huge list, or we could just kind of make up our own new one. It's free tier eligible, so that's part of the reason I want to point at this one. If you set up an account to mess around with stuff and learn things, or maybe get started doing, you have something you want to do and it's small scale, right? You're not You just want to do a few things on the internet. You're not trying to make several $1 million a week from it. Small scale, they're not going to charge you for that. They'll charge you, they can make plenty of money off the people that are trying to make several $1 million a week off the internet. So free tier eligible, 64-bit x86, that sounds like a good processor size. We have options. Do you want to use x86 or ARM? We'll just go with x86 here. That's the type of chip. The architecture is, I guess one way to think about it is the assembly language. How do those bits, we represent them as ones and zeros, but remember, it's electricity, it's like a light switch. Which light switches are on and which light switches are off, and what do those mean to the CPU? Which one means load something in RAM? Which one means run run two things through the full adder? Which combinations of switches? So the architecture design for the chip that it's running on. We're definitely not getting that detail today. The instance type T2 micro, it should default to a free tier eligible. But we have lots and lots of choices. Nanos are a little bit smaller. Then we get into small, which is twice the size of the micro, medium, large, extra large, and then we go from T2s to T3s. We have nano, micro, and lots of options. If I start scrolling, you'll notice that scroll bar doesn't really seem to appear to be moving. There's so many options here. So let's just go with that T2 micro, which should be the second one on the list. If you clicked on something else, T2 micro is the second smallest, most basic one. So just scroll all the way back up to the top, and T2 micro is free tier eligible. I have to use key pairs, don't I? So we want to control our server. We're going to do that from a terminal instruction. So we need a way to connect to it. And last week we talked, I believe key pairs were mentioned, where the public and private keys. Some asymmetric encryption. Symmetric means both Amazon and us would have the same encryption key. They use asymmetric, but that would be symmetric. Asymmetric is Amazon has one encryption key and we have another, and they have to fit together correctly. Makes it harder to encode the data. So they want us to do that, so we need to give it a name here. And not type in a new one. Oh, create a new pair. So over on the right hand side, click create a new pair. Amazon also really likes to update their website. They change buttons around and move things around. So sometimes you have to look for buttons, and some things seem to change on like a weekly basis as to try and figure out what a good way to lay out the interface is. We need to give it a name, so I'm going to call it in-class keys. Either one of those options is good. I'm just going to stick with the default of RSA and a .pim file. For a long time, SSH wasn't available on Windows machines. By default, you had to actually go and install stuff. And people tended to not use the Windows command prompt or PowerShell in order to use SSH, that's secure shell, connect to another machine and run it that way. They would not use their own, so they would install this software called PuTTY. OpenSSH has been on Windows machines for like 15 years now. So that secondary software is not really necessary anymore. So we can just stick with the default one. If you've used PuTTY before, it's out of date, but a lot of people still show it, still use it. They'll still recommend it for some reason. And yeah, either one of them will work. I was just gonna use from PowerShell, or if we even connect that way. We also have a terminal right here. We can just, this button right here opens a terminal right in Amazon. So I was just gonna use this one. That way we don't have to do it separately. But if we want to do it from our own computers, we would download this key and then we can use that to prove that we are who we are. One of those situations where passwords aren't going to be considered secure enough. So we downloaded this key, and then Amazon kept the other half, the one that goes with it. And they have to probably open that. Can I open that as a block? Yeah, I'll open it as a block. File, open. Downloads. So you can see it uses base 64 encoding. So every character on there is 6 bits. So a big, huge string of ones and zeros. And Amazon has another one that is not exactly the same, but they do have to match up. So the two will so a whole bunch of ones and zeros, way more than what you would have in your password. So a good secure way to line things up. Network setting, just the defaults are good here. We can set up different virtual private clouds, which are kind of like our own, kind of like VPNs, but they're specific to the cloud platform we're on. And VPNs would be cross network, but the VPCs stay inside the network. So we can have one in Virginia and another one in Kansas City and another one out in Portland. Portland, Oregon has the big server farm out west. Virginia and Oregon have the two big ones. But we can set up different VPCs, but otherwise it's a lot like a VPN if you've ever seen that. We make our own, like build walls around ourselves inside somebody else's network, isolate ourselves. So that's kind of what it is. The security group is how we connect to stuff. I'm going to click allow HTTPS so that way we can log in from a website or something. I don't know if we're really going to put much on the server today. We're just kind of clicking around, looking at the cloud. This one here has the IP address of all zeros. That means this is how we would restrict it. So like right now it's reading my laptop's IP address. So I could restrict it so that only this laptop is allowed to access that server. So we want to put just a specific machine, or probably machines, plural. We would just list out the IP addresses we want to have access to it. All zeros, 0.0.0.0 means any IP address. I'll allow HTTP too. I don't know if we're going to do much there because there's a couple things I want to look at. But for the most part, we can select the default options. 1 8 GB hard drive, probably good for a class example. There's more advanced options, but those are the basic ones. What did we change? We gave it a name and downloaded a key pair. Those were the only actual changes from the default. And then once you're ready, click launch instance. And it will spin that up. And then take a screenshot. If you haven't gone away from the little green bar that says success, you want to take a screenshot, and that'll be one of the, and then several screenshots to submit when we look at this stuff. Everybody know how to take a screenshot? Okay. I see heads nodding everywhere, so it's a pretty common thing. If you didn't get the screenshot taken, I'm gonna come back to the top. It's easy to get lost in all of the stuff on Google. So if you come back to services and scroll down to compute, and then go to EC2, Elastic Computing version 2, you'll get back to your instances page. And you'll notice there's 2 buttons right at the top called instances. One of them says running, and the other one just has all of them listed. Go to the list that the one that has all of them listed, not just the running ones. if you didn't get the first screenshot, just take a screenshot of it here. There's that one we created. So it has an ID, state, type of all it. We can see all of it. It's currently initializing. And it's also currently coming on about the time we normally take a break. So while we're waiting for that server to spin up, might be a good time to take a break. Everybody get it started. Just follow along. Okay, I see head nods. So 10 minutes sound good. And after that, our servers should all be up and running. My laptop says 156, so we will get back to it at 206. See y'all in just a moment, and then we'll look at a few more AWS stuff, AWS things.